I don't even really know where to begin, because it seems like every time I get ahead, I end up going 2 steps back. So tonight,
Hello and welcome once more to Mask TV with Mask Miller Learning. We are here again with a new week and a new beginnings. Grade 7s, we are here again to just do more of geometry. You know, this term is all about geometry. So today we are actually doing transformational geometry. Okay, so let's see now today the objectives is that at the end of this session you should be able to recognize, describe and perform translations, reflection and rotation with any geometrical figure. So stay tuned and stay with us for us to do it together. Okay. What is transformation? As we are busy saying transformational geometry. So transformation geometry is just all about changing the position of the shape. So if you have a particular shape that moves from one point to another, that literally simple means a transformation. So that is what we are saying. So any shape that you have, it can move from one point to another. For example, if I have this shape like this and I just shift it from here to somewhere else, doesn't matter how am I shifting it, as long as I'm shifting it from one point to another, that is transformation. Okay. So then with that, we have some part that we use as a transformation, which one is called a translation, we have a reflection, and we also have a rotation. Okay. So let's start doing the definition of what it is that is transformation and what it is that is reflection and what it is that is rotation. So this one is where we translate, right, in transformation. So translation simple means that when something moves from one point, just slide. The same shape is there, just move from one point to another. Then that is what we call it translating. It can happen going horizontal or vertical. So let me show you what we can have, okay? Let me just show you what we can have. So if we have, let's say, mathematically, let's say we have a Cartesian plane, right? And then we have a square. Let's see if we can have something like that. If I have that square there, and this square happened to move from here to somewhere else, so it doesn't have to go down or up, or it doesn't have to go sideways or down, but remember we're saying that if it comes here, then there's some sort of translation had happened, right? So if it moves to come there, some sort of translation happened. Even if it goes to the other side, even if it goes this way, for as long as it's still the same shape, then that is what we mean. So it can go vertically or it can go horizontally. It can go up or down or left and right. So that is the movement of the shape, and which here we have used an example of a letter. If I use a letter T, which is an example, and it just moved from one point to another. So if I have the letter there which moved, and then I have the same letter there which have just moved from here to there, so that is actually our sliding of translation. And also the same letter can then move down like that. So that is what we call translation, right? So you can see here, for example, we have shown the shape where it moved from this particular point. It's still the same shape, it's still the same star, we just moved that star and then it landed itself here. So it doesn't matter which direction we are moving it, it's still going to be translation. So that is one of the definitions that we had in terms of this translation. So let's look at this example, right? In the example, which you will find in our nice book, which it starts from page 208 in today's textbook. So this is the textbook I'm talking about. When you have the today's textbook, you can be able to see what it is that is there from 208, page 208 going forward. But this example is taken from page 211 of this particular textbook. Okay, so let's read it together. Remember, I always say that this is a doing subject, so we have to do it together. You cannot just sit and wait. You have to have everything, and as I move, you move. As I draw, you draw, because this is what you're going to have to do and when you are writing your examinations or your term tests. Okay, so let's see here. The example say translate quadrilateral. Remember, quadrilateral just means four-sided figure. So any figure with four sides, we call it quadrilateral. Just remember that. So if we translate quadrilateral A, B, C, D, 13 units to the right and 2 units up, right, to the image that we have there. So what that symbol means is that if I am standing at B, from B, counting these grids that I have, if I count them, I should be able to find 13, because guess what? The grids here were done per 1 unit, right? So each and every grid is done to represent 1 unit. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. One will be saying, why am I passing through the line here? It's because the point I am moving is not just the graph. I am actually moving point B, right, only. So if I move point B and I reach 13, where 13 is, then according to the statement, I must move up 2 units. So if I count 1, 2, you can see that's where my point B is actually have been translated to go to. So that's what happened. It has moved 13 units to the right, and then it also had moved 2 units up. Okay, so you do that to all. It's not only point B that had gone through that translation. All of this would go through the same thing. So if I use A, for example, I should be able to count 13 units. So let's see. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But you see where I'm getting it is right here. Then another statement said we must move 2 units up. So that is 1, 2. That's why that point is there. So if they give you A, B, C, D without them giving you the other translated space, what you do is what we are just doing now. Just look at each and every point and you count according to the statement, like the 13 units and your 2 units. You just have to remember that that is 13 units to the right and 2 units up. Then you do to each and every point that is given to you. To the C, let's do it from C. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then we move 2 units up as well. So that is 1, 2, and that is where our point is. And also D, similar thing had happened. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then we move 1, 2 units. Then after you have those points, what you do is you just take your ruler and then you join them nicely. You see the same shape have just been slided to the side and also up. So that is what we mean when we say translation. So there's no change at all. It's just that the same shape has been moving 13 units to the right and also 2 units up. You can see that. That's what happened, and that is what we are trying to say, that the shape will stay the same, which in the proper language of maths, we call it congruency. Okay, so the two are congruent. They are the same, exactly the same. So let's try to look at this activity together. While you are looking at this activity, I am going to just give you few minutes, very few minutes, for you to stay together and put your pencil, pen, and everything that you need for you to be able to do that activity, so that we can run through this, and at the end of the day, you'll be able to get it right. See you right back. I'm very sure that you have managed to get this all by yourself, because it's very easy for us to get this one. Okay, let's hop into it very quickly and see what it is that they want us to do. Also, this is found inside activities that are there in the today's mathematics, which is the textbook I was showing you, and it's going to have all this thing. It's explained very nice for you to actually understand. So let's see. I have the same shape, which is TSR. So you can actually do using this, or you can actually just look for a particular ruler like mine. If you see this ruler, if I had it like that and it was meeting very well, then I will listen to what they say and I move, or look into the diagram and I say what is actually happening. So they say this diagram here show triangle TRS, which is this big triangle, the first one that we have. So I'm just going to say 1, so that you know which triangle I'm talking about. So we have the triangle 1, which is our main triangle. So when I move to the next one, I'm going to call it 2. Then the other one, I'll call it 3. And the other one, I'll call it 4, so that we can follow each other. So my triangle 1, which is our main, is triangle TRS. And its image, they are telling you that there's an image. Some people was like, okay, image, what does it mean? They're just saying that an image, whatever that comes after transformation had happened, it's actually the other one. So we have 2, which in 2 we are calling it T. You can see there's a small arrow at the top, so we can call this one our triangle 2. And then again, there's triangle 3, which is this one with now double dash at the top. And then we have our triangle 4, which has 3 dash at the top. So these have went through 3 different steps. So they're saying that describe the transformation that will map, right? What else you have to do here is just to describe what is happening. So let's see. In 3.1, they're saying, tell us what happened from this to end up there, right? So you have to just do the same. If I come here and I say, okay, my T was here. If I move 1, 2, 3, 4, I can see that it's measuring my other T there. Then what happened? It moved 1, 2, 3. So it's simple just saying to me there was a translation that has happened. But what happened is that it moved 1, 2, 3, 4 units to the right. So that is translation, but it has moved what? 4 units to the right. Right to the right. And how many units? So it's 4 units to the right and also 3 units up. 3 units up, and then you can tell them that that is your translation. Now, what I like about this is that sometimes you find that one particular transformation had happened or 2 of them happened into one shape. It would just depend on how you are describing it and what it is that you know. So at this point, since we only know translation, that is the language that we are going to use up until we learn another language that will tell us something else. Okay, so again they said what happened from number 1 and number 3. So what happened that the triangle that is at 1 ended up on the triangle that is at 3, right? So if you look at what we have done now for 1 and 2, you will see that it was just the 12 and then it was just the, sorry, it was 4 unit, it was 4 unit to the right and then 3 units up. But if you check the one that is at the 2 here, and you also check the one at 3, they look like they have the same space. So it's like it has been moved from here to there. So what happened is the same, but there's some particular units that has been moved. So you're literally going to ignore this, but you can use it as a reference as well, the second one. So if I ignore the second one, I would still say what happened from the first one, it's like I moved 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I have moved 9 units instead. So you're going to say you had moved 9 units, right? 9 units to where? To the right. So you have moved 9 units to the right. And then what happened? When you are there, you had moved now again 3 units up, right? So and 3 units up. So that's what you say, and you will say that is your translation at this space, as we did say that this is what we know for now, and then you move, right? So that's how easy you can go about it for now, and you get that. So you can see, okay, so the only difference is that the first triangle, as compared to the second and the third, it has moved a little bit more for the third one as it is for the second one when it goes to the right, but going up it's literally the same. Okay, so let's see what happened between the first one, which is this part, up until it ended up on 4. What happened there? So if you check, for example, if I put a ruler, if you put a ruler from the T that you had on the first one and you go to the other one, which is right far, the number 4, you can see that it actually just 1 unit down for some reason. So let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this one had moved 14 units to the right and 1 unit down. So this other one had moved 14 units to the right and 1 unit down. So you can use 1 point to actually be able to describe the transformation that has happened. So this is also your translation, since it has moved to the right and also down. It can move to the right and also up, or other way around. So you just have to bear in mind that, and that's how you actually respond to this kind of questions. I hope you guys have captured that, and all this information are clarified practically in a very good way in most of our textbook, Platinum and. Okay, so let's check reflection now. Now, normally when we talk about reflection, one will say, but what is reflection? Reflection is of any shape. It's actually when there's a line in between. We literally call it a mirror, that line, to say there's a mirror line between myself and something else. And let's do this. Perhaps this can be practically properly together. So let's all take our mirrors at home or stand next to the mirror. And if you do this to your mirror like this, you'll be able to see yourself on the other side. But what reflection says is that the distance between myself to the mirror is actually the same as the distance from the mirror inside to the other side of me, that side. So you always have to just try and look at that, because it literally goes. So when I do this, as I move it far, I also go far that way. When I move it very close, I then see myself very, very close. So then the distance between myself and the mirror and that other person from the mirror, which is another me, to the mirror is the same. So please try to do that. And every time you hear reflection, just think of the mirror. Every time you see reflection, just remember that there is a mirror that has your other part on the other side. But it's similarly the same. It's just that it's reflected from one point to another. And reflection can be shown properly well with shapes. If I had these 2 rulers like this and I hold them properly like this and they're all equal, in shape, size, and everything. So what happened is the line in between these two rollers will always be the same, will always be the one that makes it a kind of like symmetry, equally in distance. So if I do this or I do this, every time the mirror line will allow me to have the reflection of the two. So either way, when you fold, if I had to fold the book or whatever, the two shapes must come on top of each other exactly. So that is a reflection that we are talking about. Okay, I hope you guys have understand that. That's what we have. So an example there, which is also taken from our Today textbook, it does show that every time there's a reflection, we do have a line which we call a mirror line, or the line that shows the image. So here they says, draw the image of triangle PRQ after a reflection in line MN. So here they are showing that if ever I had this triangle PRQ, you see, that's my triangle, and I want to draw the reflection. What happened is I just need a line that will act like my mirror line, and then what I do is I just move each and every point to the other side for it to have equal distances. So you can see that from my line MN to R itself, I have 1 unit. As well, if I move from that MN and I go to R with a small line at the top, I also have 1. So that will happen to each and every point. Even Q, if I count backward, is 1, 2, 3, 4. When I reach 5, I get my Q. If I go forward, 1, 2, 3, 4. At 5, I got my Q with a dash. So you see, that is always how we deal with reflection. And you need to always remember that the mirror line have a distance that is the same in both directions. Okay, let's see. There's an example that we have here. They say, describe the transformation of what is happening here. Just because the fact that there's a mirror line, then that's where we have to start. So what happened here is that this shape had reflected. If you see, you can see that there's a reflection happening here. But again, what happened is that after it reflected, it has moved away. So we need to first reflect it before we can say it's moved. This nice exercise, it's actually inside our today's textbook, page 214. So you can be able to see that. So let's see. From my mirror, I have 1, 2. So let's count. From my mirror, I have 1, 2. So that is what I expect to have on the other side, 1, 2. So then that means that my graph or my B was first, it came here, right? So that's what happened. So when B come here, I leave it there. And then again, what happened here is that I need to move the C to go to the other side as well. So let's say I have 1, 2, 3, 4, 5, and then at 6, that's where I get it. So let's see, 1, 2, 3, 4, 5, and then at 6, I'm going to get my C. So let me put the C there. Again, at A, I'm going to do the same thing. Here, I first check what I have from the mirror line to what I have, then I can go to the other side. Please pay attention to that. So I have 1, 2, 3, 4. That is what I have on my left of the mirror line. Then I have 1, 2, 3, 4. So that is where my A will be. So if I have to join this, basically, I would have my graph to go this way. You will be using a ruler, so yours will look more nicer than mine. So this is how the shape will practically look like before I move. So what will I say? First, you will describe this by saying that there's a reflection, right? So you can say it reflected along line MN, right? So that is your first statement. That is what happened. But after reflection, something really happened again. You can see that it has moved again. So you can see after the reflection, it has translated again. So you can see that if I reflect, if I move down and I move to the right, that's where I'll get to the shape. So let's see if we can be able to do that very quickly and move down, and then we go there. So if I have to move down, what happened is my A will have to first go to there. It's either I go to the right and I go down, or I go down to the right. Either way, there's no order. So if I go to the right, it's 1, 2. I got it there. So that is where my new A will be. But then what I did there, it is I have to do to each and everything. So remember that the ratio that I'm moving, in this case, it should be the similar one to the rest. So I have moved 1, 2 to get there. And if I move this one, I will move 1, 2 to get here, which is where C is right now. And then for me to get to where B is, I'll also move 1, 2. Do you see? So that is where my new B is. And that means my graph will then move to be like this, like there. So that's my new one. And then after I have moved like that, what will then happen is then I will then move down. But the question is how many times or how many units must I move down? So if you check where B is now, if I move 1, 2, 3, so that's how I am going to do that. So I have said first here, we have said that it is translated. We are saying we have translated how many units? 2 units. 2 units to the right. That's our second thing. And then now from there we are going to move how many units? 1, 2, 3, 1, 2, 3 down. So we're going to say again, it has been translated 3 units down. So this will be the steps that you say up until you get to the solution. So it's easy, right? It is doable, but what you have to do is practically do it. If you don't do it, like I'm trying to show you that for me to have this whole thing, I had to try and say, okay, what happened if I move this? What happened if I move this? So I'm just writing it so that you can see that if I have this shape here and I want to end up in this shape there, the thing I have to go through is that I have to look at what I have and I move around just like that until I get to the answer. Okay. So that is how you do that. And then again, we have something called rotation. Rotation is practically not a very difficult one. So if you rotate, just know that the very important part of rotation is that you always will have to have one point not moving. So suppose I'm having my book like this, and if I want to rotate, I can go this way. Do you see my point where I'm holding my right hand? It's there, it's not moving. Whatever I'm doing there, it is. I still have my point staying like that. It doesn't matter how I go. So that is what rotation is all about. One point does not move and the rest of the point will move. So that is rotation. Basically, when we rotate any shape, then that shows that we can turn around, but one point is literally fixed, right? So that's what this definition is all about when it comes to rotation. So you can check each and every shape can rotate. As for example, here we are showing that it's rotating anti-clockwise. I'm just highlighting it so that you remember. So normally when we say anti-clockwise, you guys know how the clock goes, right? Usually it goes like T, 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 like that, to the left, right? Anti-clockwise goes to the opposite. Anti just simple means opposite, right? So it's like anti-opposite for your mother, more like that. Anti the opposite of your father's sister, more like that, right? So clockwise, we go this way, and then anti-clockwise is the opposite of what clockwise is all about. If you forget, just look at the watch, and then when it goes this way, you say anti-clockwise. And every time it does that, it has to go then through 90 degrees. So that's what a rotation is all about. And you can see here, our image that was here, which is R there, had rotated 90 degrees anti-clockwise until it ended up sitting like that. So that is what a rotation is all about. So all these points, if you look at them, they have rotated or they have somehow turned around in terms of rotation for 90 degrees like that until it reached there. So that is what is all about when we talk about rotation and as well as anti-clockwise. For this, you would need to try and do some practice, then you can be able to see. Again, you can find this in our textbook, Today's Classroom Spot On, as well as Platinum. Okay, so here I have just put a quick example for you guys to look at. We can just talk this and you can put it on the chart. Let's see. I said rotation, it goes this way. So now we have learned what? We have learned all the transformational shapes that we have. One is translation, which the shape is the same, but it moves. It's light to somewhere else, right? Then we have reflection, which we have used the mirror to show how reflection is all about between yourself and the person inside the mirror, where you have a mirror line that we use to measure the reflection. And then we have rotation that goes around, but then one point does not move. That one point remained, but then the rest of the book can move. So if you look at this diagrams as well, they said the diagram show A, B, C and its image. You can see that after the transformation have happened. Describe the transformation and route the missing words. In other words, they are trying to tell you that you just have to describe what is happening here. So what you need to do is similarly to what I have been showing you, that every time you see this, before you even try to answer the question, just try to move yourself and say, I have moved this many and I have moved down this many. What happened? That symbol means that I have translated, right? So that's what they need you to do, and that's how you actually have to look at this and find the solution for it. It's actually very easy, and if you cannot do it by yourself, we always have friends for you to help you and make sure that you get into these questions. I usually just put this last slide for you to play around it, because you need to play. This is something that you have to use as what you need to learn and going forward. Here's another transformation that I have put down. You just have to quickly do the description of what this can be. What happened between the A and the A dash? What happened between the P and the B dash? And also what happened between the C and the C dash? Quickly, you can do that. And if you somehow, at any point, any given time, you get stuck, you can then ask us through Masky as well, and also through all our chats, which we have the socials, and ask each and every question that you want, let alone questions. You can also ask us or tell us what it is that you would want to watch, or how do you want us to assist you going forward. In addition to all this, please ask Masky for many, many questions that you can have in maths and any other subject. The number is 072-091-0388. You just say, hi, Masky, and Masky will assist you like a personal tutor and a personal teacher with you, just on the tips of your hands with your phone. I hope you guys have understood this transformational geometry, and you'll be able to take this to your teachers and beyond. Everybody in South Africa, we welcome to watch and actually talk to us at Masky Miller Learning and Masky TV. See you next week. Bye.
And now we enter our next exciting chapter with the launch of Maskyverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.